In a previous video, we took a look at how I like to use Shelly smart relays to control smart bulbs. I can install the Shelly device behind a regular light switch, the smart bulbs can then remain permanently powered, and the physical switch can send a command to Home Assistant to control the smart bulb. I also added a failsafe where if Home Assistant fails to control the smart bulbs, the Shelly will automatically use its relay to control power to the bulb instead. That way, in the event of any sort of Home Assistant or network outage, all my light switches fall back to working like normal light switches. And for that project, I used these Shelly 1 Minis. If you want to find out more about that setup, and especially how I set up the software side of things, then I would definitely recommend checking that video out. However, there's one catch with that setup. If we take a look at the Shelly 1 Mini, we can see that it requires a neutral connection. This isn't an issue for my house, because my house is wired using what's known as the two-plate method, where my lighting circuit is wired through each switch, meaning that I have a neutral connection available at each switch. This is very common in newer properties, however older properties may be wired using what's known as the three-plate method, and that's what I've mocked up here. And with this setup, you likely won't have a neutral behind your switches, meaning that you wouldn't be able to simply install a Shelly 1 Mini behind each switch. So in this video, we're going to take a look at two different solutions to this problem. The first, using the Shelly 1L, which is purposefully designed for this task, and then we'll take a look at a way you can actually use a regular Shelly with this setup that you might not have considered. So first up, let's take a quick look at the three-plate lighting circuit. And this is the sort of circuit you'll likely find in older properties in the UK. On the left-hand side, we have your consumer unit, and your lighting circuit comes out your consumer unit into the first light fitting. This cable contains a permanent line in neutral from your consumer unit. Then the lighting circuit loops out of the first light fitting into the second light fitting, and once again, this cable contains a permanent line in neutral. Also bear in mind that this mock-up would sort of represent what you'd have across multiple rooms. You can imagine that the light and switch on the left here are in one room, and then the light and switch on the right-hand side here are in another room. And this would continue looping through all your light fittings throughout all of your rooms on that circuit. So, as you can see, the permanent lighting circuit loops via each of your light fittings. So now let's talk about how the switches connect. Each switch is connected to its respective light fitting with a single twin and earth cable. This cable contains a permanent line from the light fitting that goes down to the switch, and then it carries a switched line back up from the switch to the light. What this means is that this cable doesn't contain a neutral, and therefore there is no neutral present at the switch that you could use to power the Shelly. So hopefully that high level explanation made sense. What we'll now do is we'll open some of this up and take a closer look at how it's wired, and that should make things even clearer. Of course, as a disclaimer, do not try this at home unless you're competent and have a good understanding of UK electrical regulations. Lighting circuits are complicated, and if you disconnect anything without knowing what you're doing, you can very easily end up in a complete mess and have a nightmare trying to put it all back together again. So if in doubt, contact a qualified electrician. Additionally, if you want more in-depth explanations of different types of lighting circuit wiring, check out videos from John Ward and GSH Electrical on YouTube. They go into much more detail than I'll be able to do in this video. Also note that at any point in this video when I take apart anything on this demo rig, I have already performed full safe isolation and tested to ensure everything is dead. Do not attempt this yourself unless you have the knowledge and tools to correctly prove it dead. Don't just turn off the circuit and check the lights have gone off and assume it's dead. Lighting circuits can be a bit of a minefield. They're often miswired in weird and wonderful ways that you wouldn't expect. Therefore, it's critical that you prove every single conductor behind the light fitting and switch are dead before you start work. And you should do this with some sort of GS38 approved tester. So first of all, here we are looking behind one of the light switches. And as you can see, all we have are two wires connected to the switch. The brown wire is connected to common, and this is our permanent line. So this wire is permanently live when the lighting circuit is energised. Then, connected to L1 on the switch, we have this blue wire that's sleeved brown. This is not a neutral. This is our switched line that goes back up to the light. So whenever the switch is turned on, this wire becomes live, and whenever the switch is turned off, this wire becomes dead. Also bear in mind that this brown sleeving should be used whenever a blue wire or incorrectly coloured wire is used as a live conductor or a line conductor. However, sometimes people won't bother installing it, or they may use a bit of electrical tape that ends up falling off, so just bear that in mind. Of course, you may also encounter wiring that uses the old colours. This will work in the exact same way, except red would be line and black would be neutral, and hopefully your switch line would have red sleeving on it. Then finally behind the switch, we have our CPC, which because this is a plastic switch in a plastic box, is simply connected in this Vago terminal out of the way. If you had a metal box or a metal switch, then it would be connected to those instead. So, that was a look behind the switch, where we just have our permanent line and switched line. Now let's take a look behind the light fitting, where all the important connections are made. So here we are behind the light fitting, and this is a fairly standard UK ceiling rose. On the right hand side we have the neutral terminals. The neutrals from the feed in from the consumer unit and the feed going out to the next light are connected in here, along with the neutral that goes off to the lamp holder. So all the neutrals are just connected together. Then in the middle here we have these terminals here labelled loop, and this is where all the permanent lines connect. We have the permanent line coming in from the consumer unit, the permanent line looping out to the next light, and the permanent line going down to the switch. And then finally we have the switch line. As we saw behind the switch line is a blue wire that's got brown sleeving on it, and we can see the other end of that over here. So this is a switch line coming out of the switch, so when the switch is turned on, this wire becomes live. And when the switch is turned off, this wire becomes dead. So that switch line then comes in here and is connected to the line that goes off to the lamp holder. So that's how it worked. All the permanent lines are connected together over here, the neutrals are connected together over here, along with the neutral that goes down to the lamp holder, and then the line to the lamp holder is connected to the switch line that comes back from the switch. Also, just bear in mind that what we're looking at here is a standard UK traditional ceiling rose, where the light fitting has all the terminals available inside it. What you'll often find with fancy decorative fittings or things like downlights is that you don't have all those terminals. So if you have fittings like that in a 3-plate lighting circuit, the loop connection will either be made in a separate connector sitting somewhere in the light fitting, or, and this is particularly the case with downlights, all of these connections will be made in some sort of separate junction box that's probably pushed up above the ceiling, leaving a single cable going into the light fitting. So again, just something to bear in mind. A telltale sign of a 3-plate lighting circuit is when you just have a single 2-core cable going into the back of the switch. The wiring in the light fitting might be a bit hidden away. So, that was a run through of how a lighting circuit is wired in the UK using the 3-plate method. The alternative you'll find in some properties is known as the 2-plate method, and this is what I covered in my previous video. I won't go into that in much detail here, however with the 2-plate method, all of the connections that are made at the ceiling rose in the 3-plate setup are instead made behind the switch. So behind the switch you'll find your permanent feed in and out, as well as a switch feed that goes up to the light. The permanent lines will all be connected together in the common terminal of the switch. The switch line to the light will be connected into L1 on the switch, and all the neutrals will be connected together in some sort of connector block. These are the neutrals from the feed in, the feed out, along with the neutral that goes up to the light. So as you can imagine with this setup, you do have a neutral behind the switch, and you can use a regular Shelly. Then behind the light fitting, it's much simpler. All you have is a line and neutral that connects to your light fitting. But we're going to be talking about in this video is the 3-plate method, where all those connections are made at the ceiling rose, and you don't have a neutral behind your switch. So let's talk about how we can use a Shelly with this setup. So, as we just saw, behind the light switch all we have is a permanent line and a switched line, no neutral. This means that if we want to install the Shelly 1 Mini that we took a look at in the previous video, or really most other Shelly devices, this wouldn't be possible, since this requires a neutral connection to power the device. But Shelly has a solution for this, and in particular it is the Shelly 1L model, and this is a Generation 3 model, although they have a few other generations of these. They also do the Shelly 2L, basically the same thing, but it has a second output for a second light. And as you can see from the connections on the device, we no longer have a neutral terminal. Instead, we have a line terminal that we connect to the permanent line from the lighting circuit, and an O terminal that we connect to the switch line that goes to the light. There's also some switch terminals here, S1, SX and S2, and this is what you connect to a physical switch, and we'll discuss this shortly. But with the Shelly 1L, you can use it as a smart relay simply by connecting a permanent line and a switch line. So, how does that work? Well, as you can see, in the diagram here, the Shelly can send power to neutral by trickling it through the light fitting. And this is how all smart switches that don't require a neutral work. These devices don't require much current, so they can safely trickle it through the light fitting and get it to neutral. If you imagine a traditional incandescent bulb with a filament, it's just a bit of wire, so you can pass current through it. And since the current is so low, the filament won't get nearly hot enough to glow. However, with modern LED bulbs, this becomes trickier, since they contain DC power supplies and capacitors. Wiring the Shelly in series with a light fitting that uses a bulb like this can cause problems. With some bulbs, the Shelly might simply not power up at all. With others, the bulbs might glow very slightly when they're turned off, and with other bulbs, the bulbs might just sit periodically flashing when they're turned off. So none of this is ideal. So to address this, Shelly include the Shelly Bypass. And this is a small device that's wired in parallel with the light fitting, as you can see on this wiring diagram here. So the bypass should be connected to the line in neutral across your light. This allows just enough current to flow when the bulb is off, ensuring that the Shelly can be reliably powered. So that's how we can power the Shelly 1L without a neutral. So now let's take a look at how we connect a physical switch to the Shelly, since this is a little bit different to the previous Shelly we took a look at. On the Shelly 1L we have 3 switch connections: S1, S2 and SX. This is different from the previous Shelly because the switch contacts no longer use a switched line. Instead, the switches should switch between SX and either S1 or S2. Interestingly, there are 2 separate switch inputs, so you could connect 2 separate switches to this Shelly. But to keep things simple, if you have a single switch, you connect SX to common on the switch, and then connect L1 on the switch to S1 on the Shelly. So hopefully all that makes sense. So now let's take a look at how we can install this on my demo rig. So, as you can see here by the light switch, we have our permanent line and our switched line. So all we need to do is disconnect these from the switch and connect them into the Shelly. So just like that, we can see that our brown permanent line is connected to the L terminal on the Shelly, and the switched line is connected to the O terminal on the Shelly. So that's all we need to do to allow the Shelly to control the light, but to connect the switch up, all we need to do is connect SX on the Shelly to common on the switch, and S1 on the Shelly to L1 on the switch. So there we go, that's now connected up as well. We have SX on the Shelly is connected into common on the switch, and S1 on the Shelly is connected to L1 on the switch. For this, I've just used some brown wires. Now these aren't technically line terminals, they are kind of their own switch terminals, but this is worth mentioning as a kind of safety thing. With devices like these Shellys and most of these other small smart relays, the power supplies in them are not fully isolated power supplies, meaning that even though these terminals aren't labelled line or aren't described as line voltage terminals, there will often be a very high voltage between these terminals and earth. So it can sometimes be 230 volts, sometimes it can be half the mains voltage. What that basically means is treat these terminals as if they're line. Don't connect a line voltage into them, treat them as independent switch terminals, but treat them as if they're line voltage. So use proper mains voltage insulated wires, don't go touching them, don't go testing it by just taking 2 wires and touching them together. You can sometimes get a shock from these devices, even using these sort of separate switch contacts. But yeah, just safety warning there, but that's all now connected up. We have our permanent line into line, our switch line off the bulb into the O terminal, and then our switch is connected across S1 and SX. So now with all that connected, we can get the switch screwed back. So there we go, that's all now screwed back. However, as we discussed earlier, these are LED light bulbs, and therefore we need to install the bypass. This is pretty simple. All we need to do is connect one wire of the bypass to the neutral connection on the light, and the other terminal of the bypass to the line wire that goes off to the light. So now let's get that connected up. So there we go, that's a bypass wired in. One wire connects in with the neutrals, and the other wire that connects in with the switched line. So it basically connects the same wires that go off to your lamp holder. However, the only thing you need to bear in mind here is that your light fitting needs to be big enough to hold the bypass. If it's not, you'd either need to replace the fitting with something bigger that has more space inside it, or you would need to find some sort of other way to safely contain the bypass, such as moving it into an external junction box above the ceiling. Also bear in mind that these wires that go to the bypass are just single insulated wires, so it wouldn't be compliant to run these wires on their own outside of the light fitting. So if you're installing the bypass externally, you need to use some sort of proper cable between the bypass in its own enclosure and the light fitting. Of course, because this is just a demo, I could have just left it like this, but what I'll do is I'll show you how to install it properly in a separate junction box. So as you can see here, I've installed the bypass in this separate junction box, connected on with a couple of connectors in there. I've then just used this bit of 2-core flex that comes out of the junction box, and we can wire this into the light fitting. So there we go, that's the bypass installed just like before, but now it's in an external enclosure. It's not the neatest job in the world because I cut off too short a cable, so the cable's very tight, and I'd also recommend if you're putting a flex into these sort of screw terminals to treat it with a ferrule, like I've done on these ones here, but this is a demo that will be installed for all of 5 minutes, so this will be fine. So the neutral and the line that go off to the bypass are connected across the switch line that goes off the lamp holder, and the neutral that goes off the lamp holder, so that's the bypass connected in there, and it's installed now in an external enclosure, which obviously you don't leave it like this, hanging out your ceiling in a real world setting. In a proper installation, you probably drill a hole in the ceiling above the light fitting, and then push the junction box up through that hole in the ceiling and leave it up above the ceiling. Then you just install the light fitting over that hole. Alternatively, you could use a larger light fitting possibly, try and find a larger fitting you can install it inside, Or you can maybe install your ceiling rose on top of some sort of conduit box like this, although one without a conduit entry, this is just the one I had to hand. But if you installed it on the ceiling, then installed your light fitting onto that, it would give a bit more space behind the light fitting, with the only sort of downside of the light fitting sort of sitting further off the ceiling, but that's another option there. But with all that done, the hardware is now complete. So now let's get this all closed up and test it out. And there we go, that's light fitting now closed up and the bypass sitting off to the side. Obviously, you wouldn't leave it like this, you'd probably put that above the ceiling or something, but that's a bypass installed as well. So now, let's take a look at it working. So there we go, that's all now set up off camera. So I've set up all the software side of things, I set it up exactly like I did in my previous video. So if you want to know more about how to handle the software side of things, then check out my other video since I go into much more detail in that video, and the process is identical when you're using the Shelly 1L. I wanted to keep this video a bit shorter, a bit simpler, and just focus on the Shelly 1L and its no neutral side of things. All the software stuff is covered in my other video. But as we can see, this works. Like in my previous video, the smart bulb is turned off, but we can see it's still receiving mains power as indicated by the green LED up here on the lamp holder. If we flip the switch, the Shelly sends a command to Home Assistant, and Home Assistant turns the bulb on. If we flip the switch again, Home Assistant turns the bulb off. And as you can see, this entire time, the green LED is on, the smart bulb is always receiving mains power, the bulb turning on and off is being controlled by Home Assistant, not by the Shelly itself. The Shelly is just leaving the bulb permanently powered. Also, like my previous video, this setup also supports the full fallback functionality. So if we disconnect this access point down here, therefore disconnecting all this from Home Assistant, and then we flip the switch, the Shelly will, after a short delay, cut power to the bulb itself. So Shelly detected that Home Assistant didn't control the bulb and cut the power by itself. And as you can see, the bulb is now turned off, and the green LED that indicates the bulb is powered is also turned off, because the Shelly has cut power to the bulb. Now, you may notice here actually that this LED is very slightly glowing, even though it's off. And this is what I was saying about the Shelly leaking current through the bulb to neutral. Even with the bypass installed, because this little green LED is such a tiny little low power LED, with the Shelly switched off, or the Shelly switching the bulb off, the current being sort of drawn by the Shelly and put through the bulb is causing that to glow a tiny bit. You can still clearly see in the demo the difference between that bulb being off and on, but if I go in and turn off the studio lights, you can see that LED is very slightly glowing even when the bulb's turned off, and that's just an effect of the fact that it leaks current through the bulbs. So if we bring these studio lights back on, it works. So as you can see, with the access point disconnected, it falls back to working like a regular light switch. And then what we can also do in this fallback state is we can take out the smart bulb and replace it with a traditional regular light bulb. And once again, with a regular light bulb installed, we can then use the Shelly, and the Shelly is controlling the light bulb directly using its relay. Like that. However, one thing I noticed is that the Shelly 1L isn't perfect. Even with the bypass installed, and the bypass is working, it actually gets a little bit warm, so I can tell the bypass is connected and working, it still isn't perfect with some LED bulbs. So the smart bulb seems fine when it's turned off, it does just generally work. This regular, fairly powerful, I think it's an 8-watt LED light bulb, that also works fine. Yeah, it's a 9.6 watt LED light bulb. This also works fine. But when I was actually testing this earlier in a previous take of this clip, I just swapped out the GU10 smart bulb for this GU10 LED bulb. And the reason I used that particular GU10 LED bulb is because this is an extremely low power bulb. I think it's only a couple of watts. And the reason I did that was just because it's quite dim on camera, so it doesn't blow the camera out. But I found that with the Shelly switched off and I used this bulb, even with the bypass installed, the current that the Shelly is sinking through this bulb to neutral is still enough to cause this bulb to glow. If we turn the bulb on, it turns on, it comes on full brightness, but with that turned off, that bulb still flickers. So as you can see, even with the bypass installed, the Shelly 1L and in general just kind of no neutral required smart switches aren't perfect. With certain bulbs that are very low power, such as these small little low power bulbs, maybe certain LED strips, decorative accent lighting, that kind of stuff, you can still have situations where even with a bypass installed, the bulbs can still have some sort of glow or flicker when they're turned off. But that's not an issue with my particular setup here, it's just a downside of these sort of things like the Shelly 1L. But as you can see with that demo, it does work. It falls back to working like a normal light switch, and when the smart bulb is installed and the smart home system is up and running, it controls the bulb smartly. So that was a run through of my setup using the Shelly to control smart bulbs. Of course, as you saw with the demo as well, it also works if you want to use the Shelly to control the bulbs just directly by turning them on and off. I just wanted to show this setup because this is how I did it in my previous video, where I used the Shelly to control smart bulbs. And this is how I prefer to use Shelly devices. I can use smart bulbs to gain features like adjustable colour temperature, but I also gain the ability to control the bulbs using a physical switch. And you don't have a sort of physical switch on the wall that needs to be left permanently on and not touched because you're using smart bulbs. It just makes things so much more seamless. And also, just like in my previous video, instead of using a traditional light switch like this that locks into both positions, we can instead use a retractive switch like this that springs back after you push it. I prefer using these with Shelly devices because it allows you to add additional actions based on events such as holding the switch down or pressing it multiple times. Installing a retractive switch is just a direct swap for a normal one. On these ones here, the labelling is even identical, so as you can see, we have common, L1 and L2. Some other brands might be a bit different on their labelling. Some might have things such as make and break or normally open and normally closed on the terminals, but it's basically just a straight swap. So there we go, retractive switch installed exactly like before. SX connected to common and S1 on the Shelly connected to L1 on the switch. So exactly the same as before, but now this is a retractive switch. And now with the retractive switch installed and the Shelly reconfigured to recognise it as a retractive switch, or button as Shelly calls it, is connected. It now works the exact same way. So when I press the switch, it turns the light on, and when I press the switch again, light turns off, press it again, light turns on. It works just like we saw in the previous video. I've also added some additional functionality for demonstration purposes, so holding the button down cycles between different colours, like that. Now, of course, flashing different colours isn't going to be particularly useful, but you could instead use this to do more useful things like trigger different lighting scenes. So, yep, it works with the retractive switch as well. And also, one really cool feature of the Shelly 1L is that it has those two separate switch inputs, which means that we can connect it to multiple switches. This could physically be two separate switches, or it could be something like this, which is known as a centre-off retractive switch. These switches are interesting because they normally rest in a middle position and can be clicked either up or down. So you could use this to trigger different lighting scenes, or even control dimming up and down by holding up and then holding down. Long press up triggers the brightest scene, long press down triggers the dimmest scene, something like that. On the back of the switch, the terminals are basically the same, just laid out slightly differently. So we have common down here, and that will connect to SX on the Shelly, and then L1 and L2, which will connect to S1 and S2 on the Shelly, and each of those represents either the up switching position or the down switching position. So there we go. Common on the switch is connected to SX on the Shelly, L1 on the switch is connected to S1 on the Shelly, and L2 on the switch is connected to S2 on the Shelly. So we now get it screwed back. Now, the only slight issue here is these centre-off retractive switches from the Click Mini Grid range are particularly deep compared to their normal switches, so it's really hard to get it back into this box. Now, it is way tighter than I would really be comfortable with normally. For the sake of a demo, I will just sort of shove it back and tighten the screws and it'll be fine for a demo, but I wouldn't really do this in a sort of real-world setting. You would really need either a deeper box or some sort of spacer between the box and the accessory, just because these are much deeper modules, which is a little bit annoying, but not all ranges do that. Other brands like MK, they're the same size, so just bear that in mind that these modules are a bit deeper, but let's get the screw back and take a look at it working. And there we go, that's now all set up. So just for the sake of the demo, I've set it up so that when I press the bottom of the switch, the light will just turn on and off like before, and if I press the top part of the switch, it'll do the thing where it cycles through all the different colours. Now, of course, in practice, you'd want to do something a lot more user-friendly, but I just wanted to show something quickly just to sort of demonstrate how that we do actually have two separate buttons here, and we can just short push both of those, and they both perform different actions. And then, of course, each of these different two buttons then have multiple long push, double press type events, so you can really get flexible with how you set these types of switches up. And now there's a final thing I want to mention, because I suspect people are going to bring this up, is that yes, the Shelly 1L is really nice and it has two separate switch inputs. I would still regard this as a device that you should only really use if you don't have a neutral at your switch. It may be tempting just to get the Shelly 1L purely for its second switch input, even if you do have a neutral at your switch. However, these non-neutral switches aren't perfect. You need to mess around with things like the bypass. You can also experience the issues like we demonstrated with this little light bulb here, where certain light bulbs can still flicker and glow even when you've got a bypass installed. So if you have a neutral available, I would always recommend using it. If you like the idea of having a second switch input, but you do also have a neutral at your switch, then I'd recommend checking out something like the Shelly 2PM. This has a pair of switch inputs, which will allow you to do something like we've done here. It also has a separate switched output to allow you to control up to 2 different lights, and it requires a neutral for situations where you do have a neutral available. It also has built-in power monitoring, which is nice to have, I suppose. So yeah, if you have a neutral and you want 2 switch inputs, I would still recommend getting something like this and not using the Shelly 1L. But if you don't have a neutral at your switch, the Shelly 1L does work really well, and that second switch input is really nice to have. So that was the Shelly 1L. But what if you wanted to use a normal Shelly, or really any other sort of smart relay or smart switch device that requires a neutral? Well, there's something on this rig that kind of gives away another option. Because sure, you don't have a neutral behind your switch, but you do have a neutral behind your light fitting. That means there's nothing stopping you installing a Shelly at your light fitting, instead of behind the switch. Of course, you're not going to be able to fit a Shelly inside a regular ceiling rose like this, but as you can see here, there are other options. For example, you can install the Shelly inside an external junction box and push that up above the ceiling. And in fact, there's a junction box made purposefully for this, the Quick Fix JB-U. If you look inside this, we can see we have space for cable entries on both sides with nice strain relief, and then plenty of space in the middle to install some connector blocks, along with loads of space to fit a Shelly. Shelly Mini is, dwarf floating around in there, and even larger Shellys like the 2PM do still comfortably fit inside this box. And using a junction box like this for a 3-plate wiring method isn't some sort of weird idea we're only doing because we're installing a Shelly. In fact, it's quite common to use junction boxes to terminate 3-plate wiring, allowing a single cable to feed into the light fitting. This is particularly common for things like decorative light fittings that have very little wiring space, or things like downlights that don't have connections for the 3-plate wiring system. So with those sorts of fittings, it's very common for the 3-plate to be terminated into a junction box and pushed above the ceiling. So if you wanted to use a Shelly with that kind of setup, you would just need to replace that junction box with something like this that's got space for a Shelly, and install a Shelly in it. So for the sake of this demo, what I'll do is I'll disconnect the ceiling rose, install a junction box in its place with the Shelly installed, and then we'll connect the light fitting into the junction box. So there we go. With the light fitting now removed, we can see we have our 3 cables. We have our feed in and out, and then we have our switch drop that goes down to the switch. Now, the only warning I'd give here is obviously on a board like this, it's very easy to identify which cables which because, well, you can see where they go to. In a real world setting where the cables are all dropping through a hole in the ceiling, you're not going to be able to tell them apart. You might be able to identify the switch drop if it's got sleeving on it, but it's not as easy as looking at a board like this. So make sure that you've labelled and identified exactly what things do before you disconnect them. Otherwise, you'll have 3 cables hanging out the ceiling and not know which one's which. But with all these now disconnected, we can now get that junction box installed. So there we go, that's the junction box rather haphazardly installed. This is far from my neatest work, but it's very late the night before the video needs to go live, and I've got a million things to do tonight, so this is the best it's going to be. But what we've done is I've basically moved all the connections that would have been in the ceiling rows into this junction box. So we have 3 connector blocks. We have one at the top here that has the permanent lines. So we have the line from the feed in, the line from the feed out, and the line that goes down to the switch. So those 3 lines are connected together. This is the same sort of connections that used to be in the loop terminal in the ceiling rows. Below that we have one for neutral. This has 3 neutrals in it, one for the feed in, one for the feed out, and one that goes off to the light. Again, this is the same as you used to have in the neutral terminals in the ceiling rows. And then the CPCs are all just in this other Vago connector down the bottom here, just out of the way. Earlier when I said the junction box has loads of room in it, it probably does if you're installing a sort of Shelly and just maybe a cable coming in, a cable coming out. When you're doing 3-plate wiring, it does start to get a bit tight. Maybe a bigger box would have been good, but it is possible. That's because I'm using the Shelly Minis. I think a full-size Shelly with this many connectors would probably be a bit of a push, but of course larger junction boxes do exist. But that's all now in there. And then if we take a look at the ceiling rows, it now looks like what we had in the 2-plate method, where we just have a line of neutral coming in, line goes off the lamp holder, and neutral goes off the lamp holder, and there's nothing in the loop terminal. So that's all now connected up. And with the light fitting put back together, we're almost ready to go. The only thing you'll notice is we have 2 wires left here, and these are the switched line coming back from the switch, and the line wire that goes off to the light. If all we wanted to do is use this junction box to terminate the 3-plate wiring, all we would actually need to do is connect these 2 wires together, because that would connect the switch line to the line that goes off to the light. And this is the connection that you used to see in the top left-hand corner of the ceiling rows. With that in there, this will now work like a normal light switch. And now as we can see with this all connected up, if we flip the switch, the light comes on. So this is now just working exactly as it did with the ceiling rows. We've just taken the connections that were in the ceiling rows and moved them into a separate junction box. So if you've already got a junction box terminating your lighting for things like a decorative fitting or downlights, this is what your junction box will be wired like inside. So all we need to do now is connect the Shelly in instead. So to connect the Shelly in, it's pretty simple. We have this connector here. Obviously this has been isolated since the previous take. But what we have here is we have our two wires. We have our switch line and from the switch and our line that goes off to the light. And now if we take a look at the Shelly, we can see what sorts of connections we require. So first of all, we need to power the Shelly, so we need to give the Shelly a permanent line in neutral. So we'll just take that from these connectors over here. So there we go, that's power now connected to the Shelly from these two connector blocks over here. So what we now need to do is connect the switch line that comes back from our switch into the switch input on the Shelly so that the Shelly can detect the state of the physical switch. So there we go, that's the switch line now connected. Now all we need to do is connect the light. So we already have the switch line for the light here, so all we need to do is connect this switch line that goes off to the light into the output terminal on the Shelly. And there we go, that's the light now connected into the output of the Shelly. So with this arrangement here, the Shelly is permanently powered from the lighting circuit, the Shelly can sense the state of the physical switch on its switch input here, and it can control power to the bulb by switching the 230 volts line voltage to its switched output labelled O. You may also notice here that I'm using a slightly different Shelly to the one I used in my previous video. In the previous video, we used a regular Shelly 1 Mini, and this worked really well. However, if we take a look at this, you'll notice that this has what are known as dry contacts. This means that the relay in this Shelly switches together the I and O terminals. This can be useful for situations where you don't want to switch mains voltage to the output, but it means that if you do want to switch mains voltage to the output like I'm doing here, you need to then put a jumper wire between the incoming line terminal and the I terminal. However, on my last video, someone very helpfully commented and pointed out that the Shelly 1 PM Mini model, which is essentially the same thing but with built-in power monitoring, instead has what are known as wet contacts. So this means that we simply have a single output and the relay just switches mains voltage from the line terminal to that output terminal. This means that we don't need to mess around with those jumper wires, and we also gain the ability to measure the power consumption of the light fitting. So that can be a really nice benefit, and it definitely makes it a lot neater and tidier than having to put jumper wires in. Of course, the only reason I'm using this particular model is so I could share this information in this video. You could absolutely use a regular Shelly 1 Mini in this setup instead. But there we go, that's everything now set up, so let's get this pushed back into the box, and hopefully I can get it all to fit. And there we go, after a fair bit of swearing and wiggling and trying to get the wires in, that's all now dressed in such a way that it shuts. So if I shut that box, there we go, that junction box is now sealed, and the Shelly's now installed. Now of course, in a real world setup, these three wires, the feed in, the feed out, and the switch drop would all come down from above the ceiling. So these three wires here would all be coming out your ceiling. You put them into the junction box, push the junction box up above the ceiling, and just have a single cable coming out, which is this one here, that goes into your light fitting. So it is a bit fiddly, it's a bit messy, it's a bit hard to work with, especially doesn't help when I'm trying to do it on a board vertically that's sliding around all over the place. But with that all in, it all fits, so it can be done. And then all you do is push this up through a hole up above the ceiling. So as you can see, you can actually fit a regular Shelly even if you don't have neutrals at your smart switches. As an alternative to a junction box, if you had a very large decorative light fitting, there may even be enough space to fit the Shelly directly inside it without needing an external junction box. For example, if we take a look at this light fitting here, there's probably enough space in this to fit a Shelly. If you take a Shelly 1 Mini, you could probably fit that in here. And this is on the relatively small side for some of these fittings. You can get ones that have quite large areas inside them where you'd be able to install a Shelly. However, the only thing to watch out for if you're installing a Shelly inside a metal light fitting like this is whether the fitting is Class 1 or Class 2. A Class 1 metal fitting like this has an earthed outer metal body, meaning that having bare wires like this inside or the Shelly sitting inside it is fine, since if any of these came into contact with the outer casing, the current could safely flow to earth and trip the circuit breaker. Where you need to be careful is with Class 2 metal fittings. With these fittings, the outer metal casing isn't earthed, and they rely on some sort of second layer of insulation around the internal wiring and connectors. This is usually in the form of some sort of separate little junction box inside the fitting, and it's usually one of those junction boxes that's so small it's almost impossible to terminate a cable into. With these types of fittings, it wouldn't be compliant to install a Shelly loose inside the metal casing, since it would be outside of that second layer of insulation. So just bear that in mind and check that the light fitting you're buying is suitable, so if you're buying a metal fitting, make sure that it's Class 1 and that the metal outer casing is earthed. But with all this put together, let's fire this up and see if it works. And there we go, as we can see, it works exactly like we had before. The smart bulb is currently receiving mains power, as you can see by the LED here, but it's turned off. If you flick the switch, it turns on, and if you flick the switch again, it turns off. And once again, if we disconnect the access point like that, the Shelly will once again fall back to working like a normal switch and control the bulb using its relay. So if we turn that off there, it physically cuts power to the bulb, turn it on again, and it gives power back to the bulb again. Works back like a normal switch. And then, as we did with the other demos, we can change out the switch for a retractive switch like this one here, so that's now retractive. Also interesting now that this Shelly is up behind in the junction box, there's now nothing behind the switch. It's much easier to work with in here, but that is now a retractive switch installed. So there we go, retractive switch now in. I'm sure you can see where this is going. We can turn the light off, turn it back on again, and if we hold the button down, it will trigger some sort of action that you could configure. Then very quickly, there's one final thing I wanted to discuss between using a normal Shelly like this and the Shelly 1L, and that is the Shelly 1L appears to have slightly higher power consumption. I noticed when I was using this, it got fairly warm, and in particular the bypass got quite warm. So I thought, well, maybe it is using some more power. I don't know quite how the bypass works. So I measured it using a power meter at the wall, and the Shelly 1L, when the output relay was not powered on, but obviously it's trickling power through the bulb, but it was not powering the bulb on, it pulled round about 1 watt. Then when the relay was turned on, it drew about 3 watts. That's also including the bulb being powered. So it drew around 3 watts while powering the light bulb. So that's not the Shelly using that itself, but this is for comparison purposes to the other one. With the bulb turned on, we were pulling about 3 watts from the wall for this entire rig. In fact, you couldn't really use the Shelly 1L if you didn't have a bulb installed because it wouldn't have anything to pass power through. But yeah, turned off, with the output turned off, it drew around 1 watt, and with the bulb turned on, it drew around 3 watts. On the other hand, with the Shelly 1PM Mini, it draws a bit less. So right now, the bulb output is all turned off, and from the wall, we are drawing about 0.7 watts. And now, with the bulb turned on, we're drawing about 1.7 watts. So it's interesting that it actually draws even less when it's powered on. Like this somehow seems to use a fair bit more power when the bulb's turned on. But yeah, just something to bear in mind. I also noticed that this makes a very slight sort of whine noise when it's in use, which I've not noticed with the normal Shellys. So the Shelly 1L is definitely a very good option if you need to install something behind your switch and you don't have a neutral. But it's definitely worth bearing in mind that just because you don't have a neutral behind your switch, while that does mean you can't install a normal non-Shelly 1L Shelly behind it, that doesn't mean you can't use one. You might just need to locate it at the light fitting, either in the fitting or in some sort of junction box, like I've done here. So there you have it. That was a look at 2 different ways that you can use Shelly smart relays when you don't have a neutral available at your switch. Either using a purpose-made Shelly 1L and Shelly 2L and use that with a bypass installed behind your light fitting, or just using standard Shelly devices and installing them at the light fitting instead of behind the switch. So hopefully you found this video interesting or potentially useful if you're looking to install Shelly devices and don't have neutrals at your switches. And if you want to find more about the software side of this setup, then I definitely recommend checking out my previous video on this topic. But all that's left to say now is thank you very much for watching.